they say SQP, it's a parallelogram. Okay. Now, S lies on the y-axis. Okay, let's just get something here. What does it mean when we say something lies on the on the y-axis? We know something about x on this line. Our x on the y-axis is going to be equal to what? To 0. So meaning the coordinates of S, they are such that good. The coordinates of S are going to be x at S, and it's going to be what? To be 0. That's what the statement means. The statement here that you saw. When they say S lies on the y-axis, they're trying to give you what is going to be x. Oh, no, I made a mistake. X is 0. No? So we're going to tell them which x is 0, but we don't know what is y. No? Our y is going to be y of what? Of S. Are we together then? Now, they say which we should determine the value of B and the coordinates of S. So we should determine the value of B and the coordinates of S. So for S, we already know one of the coordinates. We don't know this one. Now, look at this thing here. They told us with this thing here, it's a parallelogram. Now, hey, one of the properties of a parallelogram is these diagonals bisect each other. What does that mean? This one is the one that we're going to be using more often than not. When they say with something it's a parallelogram, they're trying to say which we have this M here. It's a midpoint. Now, this midpoint is going to be a midpoint of PR. It's also going to be the midpoint of what? Of SQ. Because diagonals that do what? They bisect each other. That's a property of a what? Of a parallelogram. So as you can see, I'm integrating every time. You'll see that we are taking a little bit of Euclidian and then we'll be drawing it here. So we can calculate the midpoint, man. We know how to calculate the midpoint. Actually, we know what is P. We also know what is what is R. So if you wanted me to get the midpoint, I'm going to say, okay, I have X, but you say, why don't you use S and Q? I don't know the Y value here. I also don't know the X value here. So it's a problem. I am going to tell them which X of the midpoint is X is in the middle. Right? I always start with the one in the middle. The one in the middle is going to be given by X at R plus X at P. P and R all over what? All over 2. So what is going to be the midpoint? The X value of the midpoint is going to say that I have 6 again plus minus 3 all over 2, which is going to give me minus 3 all over what? All over 2. I'm going to write it here then and say, okay, the first coordinate. Yes. Okay, it's minus 3 all over 2. Oh, 3 all over 2. Sorry about that. It's positive. And then you should always check what your answer does. It make sense. We're in this side. X should be positive. I think we're this side. So this one we get 3 all over what? All over 2. Okay, let's get Y then. How would you get Y? Exactly the way we got X. Okay. Y in the middle is going to be given by Y. Endpoint number 1 is R. Plus endpoint number 2, which is going to be what? To be P. Divided by what? By 2. And then if you do that, this is what you're going to get. We are going to get 8 as minus 1 divided by 2. It gives us 7 all over 2. Yeah, you come and update here. We have 7 all over what? All over 2. Now we have the middle point. Do you agree? We have the middle point. Okay? If we have the middle point, they say which we should tell them what is going to be B and then what is going to be the coordinates of what? Of S. Let's start with B. How will we get B? We're going to tell them again, X in the middle. Okay. Now, inline, in fact, you can tell them with inline SQ. Yeah? I want to write it here. So, inline SQ. What am I using, man? I'm using S and what? And Q. What was I using before? I was using P and what? And R. Now I'm going to be using S and Q. I have something which is in the middle in SQ. What is in the middle? I'm going to start with that. What is in the middle? It's X at M. It's going to be, what is in the end? It's X at S again, plus X at Q divided by what? By 2. But like, unlike before, I didn't know what was x in M. Now I know what is x in M. What is x in M? This is 3 all over what? All over 2. Which is going to be? What is going to be x at S? You come and check. What is your x at S? It is 0 plus what is x at Q? It's B. All over what? All over 2. You're continuing again. What are you going to do here? Cross multiply. If you cross multiply, or you can just multiply by 2, multiply by 2. If you say 2 and 2, they're going to divide each other out again. And then 2 and 2, they're also going to do what? To divide each other out. What are you going to be left with? 3 is equivalent to what? To B. So in this which our x at Q is going to be equivalent to what? To 3. Are we still fine? Now, what else do I want? I want to know what is going to be the y of S. Now, where do I start? Again, in line SQ again. So what are we going to have? We have line SQ, line SQ, like this again. Now, in line SQ, we are going to have y in the middle. We start with the one in the middle. Always, guys, don't make a mistake. No? You always start with the one in the what in the middle. Who is in the middle here? It's M. So we're going to say it's y of M, which is going to be y of S plus y of Q divided by what? By 2. But we know what is y in the middle. What is y in the middle? 7 all over 2, which is going to be equivalent to y at S. What is y at S? We don't know. We're going to call it y at S plus y at Q, 1. All over 1, all over. Multiply by 2. No? Multiply by 2, multiply by 2. It says you have 7. 7 is equaling to y at S plus 1. Take this one to this other side. It says which we have 6, which is going to be y at S. So you can come and update here and say, but now our y at S is going to be equivalent to what? 6. Now, last week, it was activity number, this is going to be a homework then. You're going to do activity, only the first one. Just do the first one.